Okay. So let f of x be -2 sine of 9x, and then it's asking about the maximum turning point and the minimum turning point. So let's look at this sine function right here. This is one sine wave. Right, so we've got this point right here, which is at x coordinate of pi over 2, y coordinate of 1. All right, this is considered a maximum turning point. I'll just call it max TP. All right, because the graph goes from increasing to decreasing, right? It's a maximum turning point. And then this point down here at 3 pi over 2 for the x component, -1 for the y component. Right, so that would be the minimum turning point down there. Right, we have a max turning point, we have a minimum turning point. Okay, so that goes up, comes down, and then comes back up. And notice that the graph starts at 0 and goes to 2 pi. So that means that this has a period equals to 2 pi. Right, remember x-intercept and then to the third x-intercept. Okay, so now let's look at what's going on with the actual function we're given. So f of x in this case is a -2 sine of 9x. All right, so remember that a negative is going to flip the graphs upside down. This 2 right here is going to stretch it vertically. Right, and we kind of did this problem really quickly earlier, but I'm going to just recap it right here. Remember that the period is equal to 2 pi over absolute value of b. In this case, my period is equal to 2 pi over 9. All right, so I'm going to do a kind of a rough sketch on this new function. All right, so first of all, the negative is going to make it flip upside down. And then the positive 2 is going to stretch it vertically. So instead of going to -1, it's going to go to +1 instead of -1, it's going to go to -2. Instead of +1, it's going to go to +2. All right, so that's going to tell me the shape of this function in the vertical direction. Again, this is upside down, so it's going to come down. Come on, stencil. Come down, come up, and then back down. That was really bad. Okay. This is what the sine wave is going to look like, right? And remember, it stretches vertically. And now let's talk about the period. So this function right here starts at 0, goes to 2 pi because it has a period of 2 pi. In this case, if my period is 2 pi over 9, this is going to be at 0. This is going to be at 2 pi over 9. All right. And so now what we're going to do is we're going to try to figure out where are these marks going to be right here. All right, so the way you figure this out is you take this number, 2 pi over 9. We're going to take half of that to get to this point. So 1/2 times 2 pi over 9. Right, well, so if you multiply that, that's 2 pi over 18, which is pi over 9, which will be this tick mark right here. All right, this is a quarter of the way. So if I say 1/4 times 2 pi over 9, that's going to be 2 pi over 36. All right, 2 times 1 is 2, 4 times 9 is 36. And if you want to reduce that, that is going to be a pi over 18. So that's going to be the coordinate right here. Right? So this is a quarter, this is a half, this is 3/4, and this is your full. All right, so I'm going to do one more time. So if I take 3/4 of 2 pi over 9, 3 times 2 is 6 pi. 4 times 9 is 36. If you want to reduce that, that's going to be a pi over 6. So that's going to be the coordinate right here. Right. So again, this is a full wave, full period. Gets me from this point to this point. So this will be the halfway point. This is going to be the quarter point, and this is going to be the 3/4 point. TQ for 3/4, Q for quarter, H for half. That tells me where these tick marks are going to be right here, here, and here. And so now what we can do is we can use these numbers now. I know these numbers here, and I know these numbers here. All right, so we started off by looking at the sine wave, the pattern for the sine wave, and then we applied the formulas from the first 7 questions to kind of figure out what is the wave going to do with this new function right here. So now that we have this, we can say that the minimum turning point has the x coordinate of pi over 18 and a y coordinate of -2. Right, so that would be the answers to part B. And then the maximum turning point has the x coordinate of pi over 6 and a y coordinate of 2. All right, so this is kind of tying all the trig functions, all the questions from number 1 to number 7 all together to analyze this question. So this would be the answer for part A. All right, starting with the sine wave, we're gonna move it around, stretch it vertically, change the tick marks to match up with the period that we're given. All right, so that is number 11. Quite a bit involved. All right, again, this is where the homework set starts to get a little complicated. Number 12 is the same type of question. This time it's a cosine wave, so I'm gonna grab the cosine wave right here. And then kind of move it down. All right, so I'm going to put the pattern right there, and we're going to use that to kind of gauge what the new function looks like. The next function in this case is 8 cosine of x over 5. Right. Another way of looking at this function is it's the same thing as 8 times cosine of 1/5 x. Right. So instead of dividing and multiply by the reciprocal right here. So in this case, my a value is 8. My b value is 1/5. Right. So again, this 8 is going to stretch these numbers vertically. Notice there's no upside down because it didn't flip. There's no negative. I'm going to do a rough sketch of this cosine function. So again, it's going to go -8 to +8 this time because of this 8 right here. It stretches it vertically. It's going to start up, come down, and then come back up. All right. So I'm going to write there's no flip because this is a positive right here. Okay. So kind of mimicking what I'm doing here, right? I figured out these numbers from the upside down and vertical stretch. Next step we need to do is figure out the period. So the period for this function is 2 pi over b. Right. In this case, the b value is 1/5. Right. So if we do keep, change, flip, 2 pi, change the division to multiplication, and then flip the reciprocal. Right. So this ends up having a period of 10 pi. Right. So this is going to be 10 pi right here. And of course, your numbers might be completely different than mine. That's perfectly fine. Remember that these tick marks are at the quarter point. This is the halfway point. This is the 3/4 point, and this is your full. All right, so let's see what's going on here. It says that my halfway point will be 1/2 times 10 pi. So 1/2 times 10 would be 5 pi. So that's the coordinate of this point right here. My quarter point is 1/4 times 10 pi. that's 2.5 pi. And then my 3/4 point would be 3/4 times the period, which is 10 pi. So 3/4 of 10 would be 7.5 pi. So that would be the coordinate of this tick mark right here. All right. So we got to be careful here. Let's look at the instructions. It says determine the coordinates to the first maximum turning point on the graph of the interval 0 to 11 pi. So if we were to remember that the sine wave keeps going, cosine wave keeps going. So there's going to be a high point right here. And then it's going to come down. I don't know what my stencil's doing, sorry. Right, so 11 pi is right around here. Right, so it says don't include 0. All right, so that means that if you don't include this point, then this is going to be my high point. So my x coordinate for the maximum turning point is 10 pi. And then the y coordinate would be positive 8. Right. So it says not include 0, so we don't include this point, but it goes to 11 pi, so that means that this is going to be part of the given interval. Right, so that's my maximum turning point. My minimum turning point is down here. Right, the x coordinate is 5 pi. The y coordinate is a -8.